another day.
Yeah. And the lectures will be held the schedules for these lecture series and the video clips of the relevant lectures will be made available in the IIA-50 webpage. And today we are very happy to have Mrs. Ras, former director of IIA, to deliver first lecture of these lectures. So
an international observational campaign. Now, the next sort of major step in the, or the next defining moment, if you like, in the history and the birth of solar physics, came with a committee which was set up, chaired by Meghnad Saha, to look at observational facilities in India, and it recommended the setting up of a solar tower telescope and a laboratory for solar terrestrial studies at Kodaikanal. And the first ionospheric and geomagnetic laboratory was set up in 1955. And soon after that, the Solar Tunnel Telescope was bought and came into service in 1960. And so after that, a new sort of era of observations began from Kodaikanal, which included 5-minute oscillations, observation of solar magnetic fields, chromospheric activity, the Wilson-Bapu effect using the calcium K and the studies of sun as a star, solar variability, the chromospheric network, and so on, and many other, which you can see on the. Now, the Kodaikanal Observatory became a part of the Indian Institute of Astrophysics that, as you just heard, was established in April 1971 as an autonomous society with its headquarters at Bangalore. And since then, the range of topics that are studied at IIA and its various centers have really expanded manyfold. I'm not going to go through the details of all of them, but some of the areas are solar interior dynamics, helioseismology, solar magnetism, which was studied for a long time and continues to be so, the corona eruptive processes, synoptic studies. I should here like to mention about the analysis of the data, because Kodaikanal has had practically uninterrupted observations for more than a century. And this has provided a very valuable treasure of data. And this data is now being examined, and various papers have already come out. I'll talk about that perhaps a little bit later. Other topics include the Sun-Earth connection. And in addition to optical astronomy, solar radio astronomy is also studied. I'll talk about that a little bit later, in which mainly the focus is on looking at flares, different types of CMEs, and so on. And solar instrumentation, which was also an area which has been going on for a long time, and more recently, study of adaptive optics laboratory has been set up, development of polarimeters, and of course, the synoptic observations of solar activity continue till today. Now, this is just showing you one of the illustrative slide of the long-term studies from the 100 years of the archival data from Kodaikanal. Now, the data consists of calcium K, H alpha, white light images, and these have been, now the whole complete collection has been digitized. The bottom figure actually shows you a digitized calcium HK spectroheliogram. And on the right, you see an image of showing you a hand drawing of the sunspot, and on the right, a comparison of the Kodaikanal sunspots with the Royal Greenwich sunspot data. And you can see that they match very well. In this study, which is based on an analysis of the Kodaikanal data, a new proxy has been developed, which is used to measure the magnetic polar fields right from 1904. So they used the Wilcox data and used that to calibrate it, and then were able to use, then extended the whole analysis to data from 1904. And this is reasonably, shows you a reasonably good agreement with observations. Other studies include the solar magnetohydrodynamics, which has been carried out by various people. And this illustrative slide shows you a relationship between the magnetic field properties, such as the inclination and field strength, and the phase, and this relation with the phase travel time of acoustic waves in the 2 to 5 millihertz range. And this shows you that, that there is quite a lot of power, more than that was previously estimated in the acoustic flux. This shows you a study of the meridional circulation using travel time measurements from HMI data. That's the heliospheric magnetic imager on the Solar Dynamics Observatory. And the pattern that you see is consistent with a single cell circulation covering the solar convection zone with a return flow close to about 0.78 solar radius. Now this image shows you the power of looking at the sun at different wavelengths, and this allows you to look at various layers of the sun. And so here you see observation from the 1 meter Swedish solar telescope. At the bottom, you see a magnetogram, and the top panels are basically images taken in iron and H alpha and off-band H alpha. So now coming to the optical facilities of the Kodaikanal, this is a collage of the different, the top 3 and the bottom 2 shows you the different optical facilities. I've already talked about the old white light telescope. In the middle, you have the Kodaikanal Tunnel Telescope, of which I'll say a little bit later, and the Twin Telescope also, which I'll say later. Then you have at the bottom left an H alpha telescope, a WARM telescope, which stands for White Light Active Region Monitor. And then at IIA, recently an adaptive optics lab has been set up. And on the right, you see the site survey instruments at Merak, Ladakh, which are being used for the site characterization of the National Large Solar Telescope. So here, the main instrument for solar observations at Kodaikanal is the Solar Tower Telescope, which has a variety of focal plane instruments, which are listed already. The names are there, so I'm not going to repeat them. And the bottom right panel shows you the twin telescope. Shows you the twin telescope, which basically takes images in white light and calcium K. And in addition, you have a digitization lab, which I've talked about, where the old images taken on photographic plates have been digitized. So now let me turn to the radio observations, which are done at IIA's Gauri-Bignur Observatory. And it consists essentially of a T-shaped interferometer array, which works in the frequency range of 30 to 120 megahertz. This, on the right, you actually see a collage of observations or instruments showing you transit activity, which was observed simultaneously by Gauri-Bignur, by the H alpha telescope at Kodaikanal, and by the scanning sky monitor on board AstroSat. So this shows a very nice synergy between various instruments for looking at the same phenomenon. Now, one of the major advantages of low frequency radio observations is that you can actually see very close to the solar limb. The conventional coronagraphs, because of the occulting disk, actually cover some portion of the region close to the limb, so you miss out on that. So this is a great advantage of looking at the sun in very low at the very low frequencies, and this is shown in this. The advantage is shown in this particular slide. Now, I'm sorry if I'm going a bit too fast, but I would like to cover the work which is done in several other institutions as well, not just IIA. So let me now turn to the Udaipur Solar Observatory, which is part of the Physical Research Laboratory. And this was established in 1975, and it was support from the Department of Science and Technology. And it was taken over in 1981 by the Department of Space and became a part of the Physical Research Laboratory. It has been, for many years, a site of the Global Oscillation Network Group, GONG. And in addition, there have been many studies on solar magnetic fields, multi-wavelength studies, and so on. The picture on the top, this is a very nice picture, sorry. Shows you the island, and on the right you see the MAST, which is the Multi-Application Solar Telescope, which was installed recently. I'll talk about that a little later in this slide. So it was commissioned in June 2015. It's a 50 centimeter off-axis instrument, alt-azimuth. It has diffraction-limited spatial resolution of 0.3 arc seconds. And on the right, you can see the optical layout. It has various back-end instruments like a narrowband imager, spectropolarimeter. It has adaptive optics. And so it has really essentially all the major back-end instruments, and it's now fully functional. So this slide actually shows you almost simultaneous observations in the photosphere and chromosphere using the narrowband imager. So you see on the left, you can see the chromosphere, and you can see the 6173, you can see the photosphere. So this shows you basically some of the capabilities of this telescope. Now, I'll just highlight some of the work. It's just not possible to go through the full list of scientific activities that have been going on here, but let me just mention some of them. The top actually shows you a line of sight magnetic field from HMI, from eruptive and non-eruptive events. And this allows you to estimate the Lorentz force and the change in the Lorentz force during the course of the event. The middle panel shows you a G-band images taken by MAST. And it shows you basically the decay of the magnetic field that takes place. And they can estimate how much the magnetic field decreases in a short amount of time. And the lower panel shows you what they call the decay index, which allows you to estimate a critical value for the onset of an instability in the atmosphere. Now, this slide shows you the interaction between two coronal mass injections, two CMEs, at a distance of about 100 solar radii. And this event is accompanied by a sudden storm, and they've been able to study the properties of that and to estimate how much was the effect of this interaction. So let me now turn to another institution, the ARIES, Aryabhatta Research Institute of Observational Sciences, which was formerly known as the State Observatory in Nainital. It came into existence actually at Banaras in 1954 and was relocated to its present place in 1965. And the main instrument there is a 15-centimeter solar tower telescope, which still continues to take observations. Main studies have been eruptive phenomena, space weather events, small-scale eruptions, and so on. And the right shows you an HA-alpha image with this telescope in an active region. Now, the purpose of this slide basically is to compare the H-alpha filtergrams with the Dopplergrams and to show that there is a very good match between the location of the H-alpha flare ribbons and the Dopplergrams. Okay, now I'm going to talk about the IUCAA, the Inter-University Center for Astrophysics. Now, here, solar physics started fairly recently in 2011. By the way, in all of the slides, I've given you the current strength of the scientists, PhD students, postdocs. Also mentioned some of the awards. I'm not going to, you can read them. I'm basically going to focus on the research that's going on in these places, but you can see that there are other aspects which are related to the number of scientists and also to some of the awards they have got. So now the main focus of research at IUCAA has been on the magnetic coupling and the dynamics of the solar atmosphere. And recently, they've also involved in the design and development of the solar ultraviolet imaging telescope suite. And this development is now going on at a very good pace. And I'll say a little bit about that towards the end of my talk. This slide of work done at IUCAA shows you basically the relationship between quiet sun and coronal holes as studied in the magnesium line. And it shows you that this line shows that the effect is stronger in the quiet suns than in the coronal holes for regions with similar magnetic fields. So this is one area of study. Another is the wave amplitude modulation in fan loops. And the main idea here is that by carrying out a wavelet analysis, you can see the increase and decrease in the wavelet power around the 3-minute oscillations, indicating the modulation. And this has been extensively examined by the authors. So now let me turn to the Indian Institute of Science, which has been over the years very active in the field. Several of the students have moved on, but I just should mention that the research areas that are pursued there have been study of rising flux tubes, dynamo models, prediction of the solar cycle, and theoretical models of the grand minima. And as an illustration, I'm showing you one of the figures from their work, which shows the streamlines of the meridional circulation. And you can find that there's a very good agreement with observations as long as there's a equatorial flow in low latitudes at the bottom of the convection zone. Now turning to IISA Kolkata, where the main activity is carried out at the Center of Excellence in Space Sciences. The main areas of study are, again, simulations of the magnetic field, and the other is the study of data-driven models of the coronal field evolution, which helps in being also able to do some forecasting. Now, this this figure is based on a simulation in which an effort is made to predict the strength of the solar cycle 25. And according to this work, the solar cycle 25 is going to be weak to moderate, similar to solar cycle 24, and it is expected to peak around 2025. And in this figure is quite interesting. It's to be able to predict the coronal magnetic field in advance before you actually can see it. And as a test of this methodology, the authors sent their predictions well in advance of the solar eclipse in what they call the Great American Solar Eclipse of 21st August 2017. And they felt that, you can see that the field lines, you get the impression that the magnetic field seems to agree reasonably well with observations. Now let me talk about IISA Pune, where quite a lot of the work is basically on solar wind turbulence, and the figure below shows you the dissipation of the solar wind fluctuations, and they suggest that the turbulence is dissipated at the proton gyro radius scale. Another new center of solar physics set up at BHU, the IIT BHU, and it's, I must say, it's quite prolific in its research output. They've been looking at solar magnetism, cycle, a variety of problems. And this slide on the left shows you how they've used the interface region imaging spectrograph IRIS and to be able to basically look at what they call pseudo shocks above active regions, and that they find that the energy in these pseudo shocks is sufficient to heat the lower corona. On the right is comparison between a theoretical model and HMI. I already mentioned HMI is the heliospheric magnetic imager on the Solar Dynamics Observatory. And so they've done this comparison and again find very interesting results based on that. Now, turning to the Tata Institute for Fundamental Research, which has been for a long time, I think also continues to be the main center for helioseismology, but the focus has expanded a bit from global helioseismology. It now includes time-distance helioseismology, and also recently some work has been done on turbulence as well. Now, the left panel, basically, I'm not going to go into the details, but it shows you, if you look at the top picture, it shows you a snapshot of a region before there's field emergence and after there's field emergence. And the group has developed a method of being able to predict the emergence of field based on some mathematical techniques. And they've compared these and they find that this technique seems to work rather well. On the right is a plot of the zonal flow velocities, and this shows you basically bands of faster than average rotation moving towards the equator at low latitudes and towards the pole at high latitudes. And it shows you the differences between the pattern during the different cycles. So having very quickly covered the type of research that is going on in in different centers in India. Let me now come to some new programs. And in particular, I'm going to talk about the proposed National Large Solar Telescope. I'm sorry, there's a mistake here. It should be Merak, not Hanle, and the ADITYA space mission. Now, the National Large Solar Telescope is a 2-meter aperture telescope with the capability, with its high resolution, having the capability to resolve very fine structure, small scale structure on the surface of the sun, especially to be able to look at small scale magnetic fields. It will be located at a dry, high altitude site in Merak on the Pangong Lake. The formal clearance is still awaited, but as you already heard, the land has already been sanctioned, and we are hopeful. It has reached a very advanced stage, and we are hopeful that the clearance should come through soon. Once the project is sanctioned, it will take about 3 years to be completed. The telescope is, we expect to buy the front end. It will be bought from an international consortium, whereas the back-end instruments will be made in-house and through national and international collaborations. And the image below actually shows you some various views of what the telescope could look like. So it's going to study, it's going to look at a variety of problems. You can read them. Basically, as I mentioned, it will exploit the ability of the telescope to look at small-scale structures. Its optical configuration is basically a Gregorian on-axis with a field of view of 300 arc seconds, spatial resolution of less than 1/10 of an arc second, high polarization sensitivity, 1 part in 10,000. It will have adaptive and active optics, and to realize diffraction limited performance, and we expect it to have a high optical throughput. Now, the last part of my talk, I'm going to talk about the ADITYA L1, which is a space mission to study the sun. It's going to be located at the Lagrangian L1 point of the Sun-Earth system. So it will be looking at the sun continuously. It will have a continuous view of the sun without any occultation or eclipses. It's in a fairly advanced stage. I'm not quite sure what the precise launch date is, but it is expected to be in about a year from now. It will have a large number of instruments, which are mentioned here. The first one is the Visible Emission Line Coronagraph, VELC, which is being made by IIA and almost complete, I understand. It will study the diagnostic parameters of the corona, dynamics and origin of coronal mass ejections, and it will study magnetic fields of the corona to 10s of Gauss. The next instrument is the Solar Ultraviolet Imaging Telescope suit, which is being made by IUCAA, and it will image the solar photosphere, chromosphere in the near ultraviolet, and also to measure the solar irradiance variations. And then there are whole other instruments which you can read. I'm not going to go through all of them, but it'll give you can see that there are, in fact, it actually, originally the project was supposed to be with only one instrument, which was basically a coronagraph, a visible emission line coronagraph. But then subsequently, when the scope of the project was expanded to go to L1, it was decided that it would be better to have several other instruments. And so as a result, now we have a large number of payloads on ADITYA. I'm going to talk about just two of these, which I touched upon in my earlier slide. On the left is the visible emission line coronagraph, which is basically a 20 centimeter off-axis paraboloid with a field of view which can go to, depending on the emission line, to 1.5 solar radius and to about 3 solar radius in the continuum. It will take images in the continuum and in spectroscopic observations in 3 lines of iron, 5303, 7892, and 10747 angstroms. It will look at the intensity in the continuum and all line parameters, and also it will study the Stokes polarization parameters, which will allow you to also map the topology as well as the strength of the magnetic field. On the right is a schematic layout of the solar ultraviolet imaging telescope, which is being made by IUCAA. Again, I believe this is in a fairly advanced state. It has a primary aperture of 140.8 millimeters. It will have a spectral coverage between 200 and 400 nanometers, field of view of 0.8 degrees of arc, and an angular resolution of 0.7 arc seconds per pixel. So these are 2 at least of the instruments in which IIA and IUCAA scientists are involved. Now, in the last part of my talk, I'd like to say a few words about human resource development. In order to be able to do good science and to be able to build facilities, to be able to sustain facilities, it's very important that you have adequate people and well-trained people to do it. Now, looking at these numbers may not be entirely correct, but I think they more or less give you an idea of what the situation is. I've just added up the faculty and student strength at the different institutes. We can see that, and the numbers in red show you the situation in 2015. You can see that the number of scientists, faculty, is more or less the same, at least over the last 5-year period. The student, this is an encouraging sign that the number of students has almost doubled. So that's a very positive sign. But if we are going to build these new big facilities, this number is going to be far too inadequate. You really need to grow more than that. And as a very conservative estimate, I think we would need to at least go for 50 faculty. And more important, we would need to have more students, postdocs, research, training staff, and technical staff, and so on. I don't have the exact figures for the technical staff, but that's also extremely important. And I apologize that I haven't said anything about the requirements as far as technical staff are concerned, but and that's purely because of the fact that I haven't really had time to be able to get that information. But it's absolutely essential that for these new programs, we need to have a much higher number of people, technical people, working on these programs. So to conclude, I would like to say that they're just sort of looking at solar physics in a sort of holistic sense. It's been an incredible journey, which started over 150 years ago with just one or two observations of an eclipse, to observations, spectroscopic observations, and white light observations at the turn of the century, and then systematically in the last 30 years or so, there has been a tremendous increase of output in solar physics. So the prognosis looks good, and it's also encouraging that if you really want to get more and more people to work in the field, you need to be able to offer them challenges. And the challenges coming out of the new facilities, I hope, will draw more and more people, more faculty, students, and technical engineers, and so on, so that this growth will be even and not lopsided, where you just have either too many facilities but not enough people to use them. So you need to have a balanced growth of the field. Finally, I have to say that I have been rather selective in the material that I presented. It's not because I consider the material that I haven't presented that is not important. It's just that I wanted to give you a flavor of what's going on in the field. The choice is purely based on what I was able to get from various people. So I was able to put these things together. I'd also like to thank various people, scientists from all the institutes that I talked about, who generously took time off and contributed material so that I could give you this overview of solar physics. Thank you so much.
Mr. Hassan? Yeah, it's now open for questions.
I have a question, Ms. Jayant here. Sirajli,
Who is this?
This is Jayant.
Oh, Jayant. Okay, sorry.
Let me turn on my camera also.
I'd like to see you.
Yeah, no, of course. The number of faculty is really a concern, isn't it? Where do you see both faculty coming from and perhaps international collaborations coming from?
Well, let's start off with the faculty. First of all, if we look at the situation, say about 10 years ago or a little bit more, the number of places, you could just count the number of places where solar physics was being done, just 3 or 4. And the capacity of these organizations to absorb more faculty was rather limited. But in the last 10 years, we have seen that several new centers have come up there. The IICAA have come up, IIT, Madras, so I'm hopeful that the universities, the missing link in this whole picture is the absence of research in solar physics in universities. And I think that unless we can find a way to address this issue, I don't think it's going to be difficult, I would say, to be able to get the numbers which are projected for the future to be able to sustain these facilities. So that's my take on the problem. Mm-hmm. It's basically, I think we need to get more people involved in universities. The number of research centers that are going to be coming up, I think, are going to be limited. I don't expect there to be many more research centers coming. So, of course, IICAA I count as universities, Institute of Science in the university, but there's very little really going on in this. In solar physics in universities. So unless that happens, it's going to be because that's where you really get the pool of students.
Yeah, this is Dipankar here. Can I just make a comment on the faculty thing again? If you could put if you put that slide on, I think what Jayant is highlighting also, which you didn't highlight, the faculty strength in IIA has only diminished. All other places it has increased. In the solar group, if you see the numbers again, from the red and the black one, in all other places, there is an increase, but in IIA, there is a decrease.
Yes,
I think that is alarming. I think that is somewhat pointing that out as well.
Yeah, I agree with you, but still, it's not the big picture. It's a very small picture because we're still talking about differences of maybe 5 or 6 people or something like that, because we need to double this faculty, and I'm not sure whether that doubling of faculty is going to be easy in this next 5 years. You're right. You're absolutely right. A large number of us have retired, and it's difficult to recruit faculty at the rate at which people have been retiring. And so that's right. The big difference has come because of the drop in the number at IIA. Yes, I agree with you.
Yeah. Anybody has any questions? Please remember to unmute yourself.
Well, just one more thing, and I hope that now, since you just mentioned a very important point about the attrition of faculty at IIA. I hope that that at least at ARIES, now that you're there, you'll be able to attract more people to do solar physics at ARIES.
Yeah, from 1 it will be 3 weeks soon. So
Let me ask one more question then.
Yeah, go ahead.
What do you think about the role of instrument development in the country, especially in solar?
Well, I mean, if we just looking at the different programs, it's like very much what's happening in other programs, that the instruments. I agree. It's absolutely crucial. It's a crucial area which hasn't yet been received the attention that it deserves. You may remember that Dr. Govind Swarup, every time he used to visit IIA, he would say that, listen, what are you going to do to build up your instrumentation capabilities? I mean, the human resources in the instrumentation. And he even used to go so far as to say that there should be separate institutes, where instrumentation should be done. So how the institute or the various institutes are going to, which direction they will follow in addressing this problem of not having sufficient people and sufficient programs in instrument development. I don't know. I can't say that. That is up to we have at least 2 heads of organizations in this audience. But I think what is, I think it really is important that we be a little more aggressive in our recruitment. We need to start actually trying to go and grab people, if I may use that term, because just waiting and in the hope that the fact that we have such a wonderful programs and people will just come. I mean, that is there, of course, and that will continue to be there. But we need to be a little more proactive to do that. The types of, I would say, for example, at IIA, it's been a positive step as far as NLST is concerned, that work has already begun, for example, on adaptive optics, basically on prototype design. There is a MOU which has been developed with the USO, with PRL. So hopefully these programs, once the NLST gets the formal sanctioned, I expect that we should be able to recruit many more people. But I'm not sure that is going to address the big question about instrumentation development in the country. These are just some steps. I really don't know the full answer to this question, but I think we need to sit there and do some brainstorming on it.
If I may make one more comment.
Yeah, please, Pankaj.
Okay. Yeah, thank you, sir, for just giving 150 years of journey. It's all started from this eclipse experiment. So I thought I will just mention another major contribution from IIA has been the eclipse expeditions from IIA, and I must compliment Professor Jagdev Singh and your support over the years. This is, I think, an important experiment which not many people are able to continue, and somehow that has also not continued in recent years. So this may be kept in mind. We do have a long tradition of eclipse experiments, and it has produced important results in different times.
Yeah, thank you, Dipankar. I'm really sorry. I completely neglected this part. You're absolutely right. We have, I remember going on at least 3 or 4 eclipse expeditions, and some of the new programs which were started with you and Jagdev Singh and various other people, and which have also led to some papers, especially on the high frequency oscillations in the corona. And I'm sorry that I have not been able to touch on it, but you're absolutely right. Eclipse studies have also been a major activity in the past of IIA, and have also contributed to basically some new information about the sun.
Even the new design of the coronagraph, we do still use eclipse data for calibrations.
Okay, thank you. Yes.
Professor Hassan, there's a question by Dibyendu who's watching this whole thing on YouTube.
Yes.
He wants to know if there is some clarity on the current status of NLST. I know you mentioned it in the talk, but maybe he missed that. Could you please?
Well, I think there are other people in the audience who can say something, but I'd like to say that as far as my understanding is concerned, it had reached the final stage where SFC or EFC, whatever the right term is, meeting needs to take place. So it's just at that final stage. That meeting was supposed to take place at the DST last year. It got delayed for various reasons. And then the pandemic has also upset the situation considerably. But it is at a stage which is very close to approval. But I think perhaps Dr. Annapurni, the present director, might be able to shed more light on this situation.
So you're right, Professor Hassan. So we were supposed to have a meeting with the DST regarding the financial matters and approval of the entire budget, etc. by March, but we could not have conduct that. And right now, this is getting bundled with the next financial 5-year term, whole financial plan. So that it's going into that block. So we have submitted the necessary requirements for that and to the DST, and they are putting it all together with the requirements of the DST in the next 5 years, and putting it for the approval. So we'll have to wait for a few more months for the approval to come. That's what I understand.
I just saw a comment by Nandita. Has somebody seen it?
Yeah.
Yeah, you can just read that out. Yeah.
Just read it out. Nandita says that we should acknowledge contributions of IIA in making new facility in the country, especially Dr. Bhatnagar, who did PhD thesis on the Vershed effect in sunspots in Kodaikanal Observatory with Vainu. Later, his interest in solar astronomy led to establishment of USO.
Absolutely right. I overlooked to mention that the setting up of the Udaipur Solar Observatory was due to the painstaking efforts of Dr. Arvind Bhatnagar, because at the time he really had to fight very hard to get some money to start it off, and then finally to get the Department of Science and Technology to actually provide funds for the observatory. So yes, you're absolutely right, Nandita, and Dr. Bhatnagar has played a very important role in solar astronomy in the country.
Okay. Any further questions or comments? If not, let's thank Professor Hassan for a very informative lecture on the growth of solar physics in the country. And there is one question. If I think I can take it. It's from Durgesh.
Yes.
Yeah, he's on YouTube, and he asks, do you think India should aim to join and invest international observing facilities, or focus more on developing facilities in India? What is more beneficial for hiring new faculty?
I think it's not either or situation. I think we need to do both in some balance. I don't think we should just take the view that no, we have no time to participate in international collaborations because we have our hands full, because it's very important for the overall development and for us as an international facility. You see, we have to look at that all these facilities that we are developing, they're not just facilities for astronomers in India. These are facilities which should serve the international community of scientists. And I think it is important that we take both steps. We should not sort of forego and say, look, at this time we have no time. We have to just focus on our national programs, and we will take up when you're ready to take up the international collaborations, the international collaborators may not be ready for you. So I think you need to keep that link. And it's important to do it in the right balance. What that balance is something which has to be worked out by the scientists and the leaders of the various institutions. But it is important that both those options should be kept open. Thank you, Durgesh, for this comment.
Thank you, Professor Hassan. I now hand over the proceedings to Aruna.
Thank you, Anupama. So we have now come to close to the end of the meeting. And once again, on behalf of the IIA-50 organizing committee, I take this opportunity to thank Professor Siraz Hassan for a very exciting lecture with wide scope and in-depth coverage on a topic of great research interest. I also take this opportunity to thank our director and dean for their constant support, and my sincere thanks to all the participants who have joined us today, either through WebEx link and YouTube live stream, for their active participation. So we look forward for your continued support. Thank you, everybody.
Yeah, thanks so much, Professor Hassan. It was very interesting talk. Thank you.
Thank you.